Hello, good evening, everyone. Am I audible?
Good evening, ma'am.
Good evening, ma'am.
Yeah. How are you all? Have you started watching the content?
Yes, ma'am.
Okay, so how are you feeling about week one? Is it easy or tough or moderate?
Easy.
Yeah, so week one is quite easy. Okay, so before we start the session, let me tell you a few things. So we will have two types of session.
Ma'am, your voice is low.
Hello.
Yeah,
Now
ma'am. Fine, fine, fine.
is it fine? So we will have two types of session per week. So one will be your solve with us session, and the second will be doubt session. And we will not have summary session from this words or from this term onwards. Okay. So I would suggest you all
Okay, ma'am.
to study the topics before you join the session. Then it will be helpful. Okay.
So, ma'am, what is this session for? This is a solve
So
with.
yeah, this is solve with the session. So we will see the questions. We will solve the questions based on the topic of week one. And
Okay,
in the,
ma'am.
yeah, and in the next session we will take the doubts. So if you have any doubt, you
Okay.
can ask in the doubt session.
Okay, ma'am. So this is a solve with the session,
Yeah,
and maybe some doubts come in between the questions. Then
yeah, you can
we can.
definitely ask. Yeah.
Okay, ma'am. So, ma'am, this is a TA session, right?
No, no, this is instructor session.
Okay.
Yeah, ma'am, today we receive a mail that
Madam,
our
multiple
will not.
voices are coming from here, madam.
Please speak one by one.
Yeah, ma'am,
Yes.
may I speak?
Yeah, yeah.
Ma'am, today we receive a mail that we will not the recordings will not be provided from this term. So, is it apply for this session also? This type of
No,
session also?
no, it will be provided.
Okay,
So,
thank you.
ma'am, every session recording will be provided, be it TA or instructor session.
Instructor session will be provided. TA, I'll have to check.
Ma'am, please, if TA session would also been provided, it is actually important. Questions are solved in that.
Okay, we'll see that thing, but instructor session will be provided to you.
So, ma'am, next session will also be instructor session or TA session.
So every day you like on Sunday and Tuesday we will have instructor session, and on the other days you will have your TA sessions.
On
So you
Sunday
can
and on Sunday and
Sunday and Tuesday will be instructor session.
okay, okay.
Okay, and on other days it will be TA session. So you can check everything on your calendar.
Okay.
Ma'am, I didn't get any invite in my calendar. I sent a note to support team as well.
Have you subscribed to the calendar?
Yes, I do.
You
It
have to
should be there
open
only.
the notifications of that through the calendar.
Notifications.
But ma'am, earlier TA sessions also used to be recorded, right?
Yeah, earlier it was like that, but from this term there are some changes.
But ma'am, these changes have not been made for, I think, very long time. So can you please consult with the other instructors as well to just record all the TA sessions also?
So for TA session, we will see what we have to do, whether it will be recorded or not. But instructor session, you will get the recordings on YouTube.
Means it just takes to press a button to just stream it on YouTube, right?
Yes, yes, we already have a discussion about this thing. So
Yes, ma'am, please.
Ma'am, I'm a working professional and I've been trying to catch up on the syllabus, but week zero content itself is very vast. I do understand that it is some of the basics, but I didn't get a chance to go through the week one content yet. but when you solve today's session, will you cover some of the basics so that I can
Yeah.
understand?
Yes, I will give you the overview of all the topics. I will not go into the detail, but yeah, I will tell you the like formulas or the basic things that are required to solve the questions.
Okay.
Madam, can I know your good name, madam? So we don't know whom we are talking here.
Yes, my name is Prerna.
Okay.
So, ma'am, just to be clear, so this session will be recorded.
Yes, yes.
And we can access this at later time. But the TA sessions will not be recorded. Is my understanding right? Just for
TA session, it's not confirmed for the TA session, but for instructor session, you will get the recordings.
So, ma'am,
Okay.
there is discussion going on for TA session whether they will be recorded or not.
Yes.
Okay.
So, ma'am, in this session, there is no summary session.
Yeah, it will not be a summary session as it used to be earlier.
And I think we should start at 16.
Yes. Okay, so now we can start with the session. Okay. I hope my screen is visible.
Yes, ma'am, it's visible.
Yes, ma'am, it's visible.
Okay, so in week 1, you have studied, if you have seen the content, we have studied multiple random variable and like joint PMF and conditional PMF and marginal PMF of 2 or and more random variables, right?
Yes.
Okay, so first of all, if we have 2 random variables, then how we denote the joint PMF? Okay, so suppose x and y are discrete random variables. So in week 1, we have to study about only discrete random variables. Okay. So how can we denote the joint PMF? Anyone?
Through a table.
Yeah, that is fine. Okay. So we can write it like this: f x y, and suppose x is taking value t1 and y is taking value t2. And since they both x and y are discrete random variable, we can also write it like that. It is nothing but the probability that x is taking value t1 and y is taking value t2. Okay. So this is how we can write the joint PMF of 2 random variable. Okay. Next, we have to see how we can find the marginal if we are given the joint PMF. So the marginal is so how can we write the marginal of x? Anyone?
P of x is equals to t1.
Okay, I am asking if we are given joint PMF, then how can we find the marginal of x? So it is nothing but the probability x is taking value t1, that is right, but how can we find it? By using the joint PMF. So what we have to do, we have to take the summation over the joint PMF. And what should be the range here? Range of summation, anyone?
T2, ma'am. T2 belongs to Ty.
Yes. So we are finding out the marginal of x. So we have to take the summation over the range of y. Okay, so we can write that T2 belongs to Ty, or here also we can write that T1 is something which is belonging in this range Tx and T2 is belonging in T1. Okay, similarly we can find for y also. Okay, so this is nothing but probability that y is taking value t2, and this is summation. So here we will take the summation over t1. Okay, now next we have to find the conditional PMF. So how can I find this? We
Joint
have,
PMF upon marginal PMF.
yes, so joint PMF of x and y. Okay, and the marginal of x or y?
Ma'am, why?
Right.
Marginal of y. Okay, and this is nothing but the probability that x is taking value t1. Okay, and y is taking value t2. And in the denominator it is probability that y is taking value t2. Okay, so similarly you can find for y given x also. Okay, is it clear to everyone?
Yes, ma'am.
So far, ma'am.
Yeah. So next thing, if you have seen the content, there is when if you have a random variable, suppose n, which is following Poisson distribution, okay, with parameter lambda suppose. Now, given that this random variable capital N is taking value, suppose small n, and then what we are doing, we are tossing a fair coin. Okay, n times. We will see a question based on it later. Okay, and we are denoting the number of heads obtained by x. Okay, so basically x is a random variable which is representing the number of head obtained in the uh, n flips of a coin.
Ma'am,
Yes.
can you please also explain how to identify how to identify if a distribution is Poisson or not in very short, just for help?
Uh, okay, so Poisson distribution is basically it gives you the number of success in a time space, in a time interval, or in any space. Okay, suppose you are counting the number of errors in one page. So one page you can consider it as a space, and number of errors. Okay, so that you can model by Poisson distribution. Okay, and
So
in
basically,
binomial
so
distribution,
basically, we are considering a fixed interval of time or fixed interval of space, right?
yes, yeah, and in that interval of time or particular space, we are counting the number of events happened. Like how
So we
many
will
times a
define,
particular event has happened.
okay. So we will define an event and we will count the number of event happening in an interval of time or space, fixed interval of time or space.
Yes.
Okay.
Ma'am, lambda is the average, right?
Yeah, lambda is the mean in this distribution, and it is a parameter also. Okay, so as far as we have a random variable n, which is following Poisson distribution, and then we have another random variable x. Okay, so what we are doing here, we are tossing a coin. Okay, as many times this value. Suppose capital N is taking value small n, then we are flipping a coin n number of times, and in that n number of times we are observing that how many times we are getting hits. So now how can we find the distribution of x? our objective is what is the distribution of x here. Can you guess?
It's a Poisson distribution.
See, n, capital N is following Poisson distribution, not
It should
x.
be binomial, right?
Yeah, it should be binomial. So first of all,
Binomial.
yeah. So capital N, okay, its distribution is Poisson, which is e to the power minus lambda, lambda to the power n divided by n factorial. Okay, as capital N is taking value small n here, and n can take values 0, 1, 2, and so on. Now we have to find the distribution of x given that capital N is taking value small n. This is something we have to find. So this will follow the binomial distribution. So for binomial distribution, we have two parameters, right? Number of trials and the probability of success. So can you tell me what should be the parameters here?
N and 1 by 2.
N and 1 by 2. So how is it n? So you can see that we are flipping the coins n number of times. So the
Small
number
n
of
means.
trial, yeah, small n, sorry. So the number of trials are small n here.
Ma'am, why binomial है?
So what do you understand by binomial distribution first? It gives you number of success in n independent trials, right?
Yes.
Ma'am, just for clarification, in binomial distribution, we are considering each trial is a Bernoulli trial, so it will have a output as 0 or 1, may it be any number, and each trial is independent. So n will be denoting the successes, number of successes which we define success, and next will be the probability of that success.
Yes. Okay.
Okay.
So here you can see what is x. X is representing the number of hits in and number of flips of a coin. Okay. So number of trials for this binomial distribution will be small n. Okay. And since we are having a fair coin, so the probability of success will be 1 by 2. Right. So now the distribution of x given capital N, it will be binomial distribution. Okay, don't worry, we will see a question, so it will be more clear. Okay, so now we have seen marginal and joint and conditional for two random variables. So next we will see the same things for multiple random variable. So if we have multiple discrete random variable, okay, so suppose x1, x2, xn are discrete random variables. Okay, so now how can we write a joint PMF of all x1, x2 up to xn? So we can write it like this: x1, x2 up to xn. Okay, and these are taking values t1, t2 up to tn. And what it is actually, this is nothing but the probability that that x1 is taking value t1 and x2 is taking value t2 and so on, xn is taking value tn. Okay, is it clear? And we can write that this ti is belonging in this range, capital T xi. Okay, so this is the joint PMF for multiple random variables. Okay, now we can see how we can find the marginal. Okay, so suppose we have only three random variables. suppose we have x1, x2 and x3, okay, which are following some distribution, okay, and each exercise is belonging in this range, okay. So now if we have to find joint PMF of x1 and x2, suppose, then what should I do? How we can find it?
Ma'am, we have to make x1 and or t1 and t2 constant and sum all the t3 multiple random variables.
Yeah, so first of all we can write it like this, that x1 is taking value t1 and x2 is taking value t2, okay, these two are the same things. Now if we have to find this joint distribution of x1 and x2, when we have the joint distribution of all the three random variables, so we have to take the summation over this joint distribution x1, x2 and x3, okay. And since we are finding out the PMF, joint PMF of x1 and x2, so we have to take the summation over the t3, right? Is it clear?
So, ma'am, here we are fixing two random variables and taking summation over the next one.
Yeah, over all the other variables.
Over
So
all the other, yeah, here there are
yes,
only three.
yeah. So here we have only three variables. So x1, x2 we are finding out. So we will take the summation over t3 or x3, we can say. Okay. So similarly, I can write if we are finding for x1 and x3, suppose. Okay, then it will be something like, okay, this is T1, T2 and T3. So now you can see we have x1 and x3. So the remaining variable is x2 only. Okay, so we have to take summation over x2. Okay, so which is T2. And now if we have to find the marginal of,
Ma'am, I could not understand this notation which you are writing for multiple random variable.
uh, okay, don't get confused with the notations. This is nothing but that we have three random variables x1, x2 and x3, right? And this t1, t2 and t3
Yes.
are the values which are taken by these random variables.
Okay.
Okay, so we are saying that this t3, like we have to take the summation over the other variables. So we have here t1 and t2, like sorry, x1 and x2. So we have to take summation over the range of x3. So x3 is taking values like, so we are representing that x3 is taking value t3. So that's why we have written here t3. Okay, you just
So
try to
when we
understand what we are doing. Don't get confused with the notation, as you don't have
no,
to write the notation in the exam. So you can,
okay,
yeah, you can use different notations as well.
Ma'am,
okay.
the second line but which you have written x1 comma x3 t1 t3, there we should have the t2 belongs to tx2, right?
Sorry, yeah, it's x2. By mistake, yeah, it is x2 only. Okay.
So, ma'am, for here we are trying to find the marginal probability by clubbing two random variables over the third random variable.
Yeah, so we have, like, this is for multiple random variables. So if you
Yeah.
have like more than two
Here,
random variables,
yes.
okay, and if you are finding out the joint of any two, suppose you have more than two random variables. So here we have three, or you can have more than three as well.
Okay.
Okay, so you can find the joint PM of two random variable as well, three random variable as well, out of the n random variables you are given.
Okay.
Okay, so what you have to do, whatever random variable you have to find the joint distribution of. just leave those random variable, and what are the remaining random variables, you have to take summation over all those random variables. So see, here we are taking two random variables. Now if you have to find the marginal of x1 only, suppose, okay, so again what we have to do, we have to take summation x1, x2 and x3. Okay, this is t1, t2 and t3. So now what will be the range for summation?
X2 X2 from belongs to T capital T to, okay, yes, yes,
Yeah,
this one.
okay. So over T2 and T3, or you can say the
And
random
same for
variables
T3.
x2 and x3.
Okay.
Okay. So you just remember that if we are finding out the marginal of x1 only, okay, so we will take the summation over the ranges of x2 and x3. Okay.
Okay.
Whatever
Above
random
above
variables are
above
left,
above two also were the marginal ones, right?
these are
These two.
like, you can say, the joint PMF of x1 and x2, and this is the marginal of
Okay.
one single variable only.
Okay.
Okay, since
Okay.
we are having multiple random variables here.
Okay.
Okay, now is it clear to everyone how we have to take the range? Similarly, we will
Yes.
see one case for conditional PMF as well. Okay, so for conditional, if you have to find the f, suppose x1, okay, x1 given x2 is equals to t2, and here x1 is taking value t1. This is same as like as we have seen in the two variable case. So it will simply be the joint PMF of x1 x2 divided by the marginal of x2, right? Now if we see for multiple case, so if we are given, suppose x1 comma x2 given, x3 is taking value t3, okay, and for x1 it is t1, for x2 it is t2. If you have to find this conditional probability, so first of all, in denominator, whenever we are finding the conditional one, in the numerator, it will always be the joint PMF. So basically, we have to take the joint of x1, x2, and x3. Okay, so it will be x1, x2, and x3, t1, t2, and t3. And in the denominator, you have to take the marginal of whatever is given in the given, like in the conditional. So you can see it is x1, x2 given x3. So you have to take the marginal of x3 only. So it will be fx3 t3. Okay. Now one more case I can write. If you are given like x1 given x2 is equals to t2, comma x3 is equals to t3. Suppose this is you have to find. Then what it should be?
The marginal will be of 2 and 3 both.
Yeah.
In
So
the
in
denominator.
numerator, yeah, in numerator it will be the joint of all the three, x1, x2, and x3. Okay. Then t1, t2, and t3. And in the denominator, it will be this thing, right? So basically, it is f x2 and x3, t2, comma t3.
So denominator will be joint probability of x2 and x3.
Yes.
Okay.
Whatever is conditioned, you have to take the probability of that in the denominator.
Okay.
Okay. So now we can start the questions. So this is your first question. Try to solve it. So So we are given the joint probability mass function of two discrete random variables x and y. Okay, so this is a PMF and this is the range. You have to find the marginal distribution of x. Try it first, then I will solve it. So how are you doing this?
First, I'm making a table for it so that it will be easy.
Okay. You can make the table or you can just directly put the values. So what you have to do here, you just have to take the summation of this joint over the range of y. Okay, since we are finding the marginal of x.
Ma'am, can you scroll up so I can take the screenshots of the
Ma'am,
above
is it a
notes?
7 by 36?
You want the PDF, right? The solution. So this PDF will be uploaded on the portal. Okay, so you can take it.
Ma'am, where we can find this PDF?
So this PDF will be
Excuse me, ma'am.
uploaded in
Hello,
the live session notes.
ma'am.
Yes.
Ma'am, I am joining. Just can you tell me this is a summary session, ma'am, for week one?
This
Stat
is the
second.
solve with the session for week one.
Okay.
Okay, so we will not be conducting any summary sessions. But I have given the
Mhm.
overview of week one. But you have joined late.
Ma'am, is it a 7 by 36?
Ma'am, marginal distribution of x is 9 by 36, 12 by 36, and 15 by 36.
Okay, so we will solve it and we'll check the values. So we are finding the marginal of x. So it will not be a single value. It will be like three different values. Okay, so now I am solving this question. So we have to find the marginal distribution of x. So we represent it by this. Okay, so this is the capital X and this is a small x. So let me clarify one thing, that capital letters, okay, are used for the random variables and the small letters are used for the values that random variables are taking. Okay, so if I'm writing it like this, that capital X, so and here small x, which means we are having this marginal PMF of capital X random variable at the point small x or the value small x. Okay, is it clear? Okay, now we
Yes,
will
ma'am.
use the formula that we have seen earlier. We have to take the summation of this joint PMF, okay, over the range of y. Okay, we will use the simple notations here. So we have to take the summation over the range of y. So first of all, you can see here that y is taking values 1, 2 and 3. X is also taking the same values 1, 2 and 3. So here we need the values of y. So it is going from 1 to 3. Okay, now next we will write the joint PMF, which is x plus y divided by 36. Okay, now we will open this summation. So x plus y. So y is taking value of 1. Then next value is 2. So x plus 2 divided by 36. Okay. Then x plus 3 divided by 36.
Plus 2 by
30.
36.
So it will be 3x plus 6 divided by 36. So if you solve, it will be x plus 2 divided by 12. Okay, so this is the marginal PMF for x. And here you can see that x is taking values 1, 2, and 3. So you can put the values and find the value of probability for each different values that x is taking. You can make the table also. So it will be like this, that x is taking values 1, 2, and 3. Okay, and the effects, or you can say the probability. So this will be 1 plus 2 divided by 12, right? Here it will be 2 plus 2 divided by 12, and here it will be 3 plus 2 divided by 12. Okay, so this is how you can find the marginal PMF. Is it clear? You can solve this value.
Yes, ma'am.
Any doubt? Anyone?
Can you explain it again?
Okay.
Start.
So whenever you have to find the marginal, you have to take the summation over the joint PMF. And the range you have to decide like this, that you have to find the marginal of x. So whatever the other variables are, you have to take the range over those variables. So here we have two variables only. So we are finding the marginal of x. So we will take the range of y. Okay.
Yes,
So
ma'am.
what we have done, we have the range of y is 1, 2, 3 only. Okay. So y is going from 1 to 3, and we have written the joint PMF of x and y. Then you just have to put the values. You just have to open the summation, right? Simply. So x
Yes, ma'am.
plus 1, then x plus 2, and then x plus 2. Okay, we have put the values of y here. Then we just have solved it. So this is the marginal of x. You can write it in this way also. Or if you want to make a table, you can write it like this. So x is taking values 1, 2, and 3 here. You can see in the question. Okay, x and y both are taking values 1, 2, and 3. Okay, and for each different values of x, you can use this marginal PMF and find the probability for different values of x. Okay, so if x is 1, you can put the value of 1 here. When x is 2, then just put the value of x2, and then 3.
Okay, ma'am. So we have to take the other variables except the one we have to find the marginal PMF of. We have to take the variable we have to find it to be any variable like x. We
Yeah.
don't have to change it.
So suppose you have three variables x, y, and z, and you are finding the PMF of suppose z. Okay, you are finding the PMF of z suppose. Then you have to take the summation over the range of x and y both.
Okay.
Okay, it is like this.
Ma'am, what is the importance of zero in that the question? You have
Yeah,
zero.
zero. Yeah, zero is like if you are asked to find the marginal of x at suppose at 4.
Okay, ma'am.
Okay, so if x is taking any other value apart from these values, then the PMF will be 0. Sorry, it is for joint.
Okay, so anything out of the range, you have to take zero as the value.
Yes. Okay, so this joint PMF is defined on this range only. When x and y are taking value 1, 2, and 3.
Okay.
For all the other values, it will be 0.
When we are talking about two random variables, then it is actually easy to imagine in the form of a table. But when we are talking about three random variables, then how we can imagine it in form of a table?
We will see it later. We have questions on multiple random variable as well. Okay.
Okay, okay.
Okay, so you have find the marginal of x. Now try to find out the marginal of y. Okay, so I'm representing the question only. You have to find the marginal of y. Next.
Could you please repeat the question, ma'am?
You have to find the marginal distribution of y. See, this is the question. You have to find the marginal of y. Okay.
It would be same as the x, I guess.
Yes, ma'am, it's fine.
Yeah, you can say it will be similar in that way only. As we have find the x, answer will also be similar. Same steps you have to follow. Just try to solve it.
Ma'am, is there a possibility that X can have a different range and Y can have a different range?
Yes, yes, this is also possible. Okay,
Because
suppose.
ma'am,
Yeah.
because ma'am, in this question, the base equation is also same and the range of x and y is also same.
So range of x and y can be different also or can be same also.
But in this question, it is same. That's
Yeah,
what
in
I'm
this
saying.
question, in this question only it is same.
So if the range of x and y are different, then the marginal probabilities of different variables would be different. X
Yeah,
and
it
y.
will be different.
Same.
Yeah.
Okay.
Is it done?
Yes, ma'am.
Okay, so it is same as the previous one. You have to find the marginal of y. Now you have to take the summation over the range of x. Okay, so here x is also taking values 1, 2 and 3. So x plus y divided by 36. Okay, now you have to put the values of x. So it will be 1 plus y divided by 36.
2 plus y.
And then 2 plus y divided by 36. 3 plus y. Okay, so it will be 3y plus 6 divided by 36. Okay. So y plus 2 divided by 12. Okay, you can make the table if you want. Okay, y is taking values 1, 2 and 3 only. Is it clear to everyone?
Yes, ma'am.
Okay.
Yes, ma'am.
So far, ma'am.
So this is your next question. I am writing the joint PMF here. Okay, so the question is x plus y divided by 36. Okay, and x comma y are taking values 1, 2 and 3. Okay. So now you have to find the probability when x plus y is equals to 4.
Ma'am, where to get this PDF?
It will be uploaded on the portal in supplementary content.
Ma'am, is it 1 by 3?
Solve it. Anyone else who have done this?
1/2.
Okay, how we will solve it? What's your first step?
We have to take the cases, ma'am.
So what will
So
be the
what will be the
cases?
cases? 1 3, 2 2, 3 1.
So should I solve this question now?
And then add them.
Yes. So we have to find the probability of x plus y is equals to 4. So as you can see here that x and y both are taking values 1, 2 and 3. Okay. So we have to see where the summation of x and y can be 4. So the first value of x is 1. Okay, so if x is 1, then what should be the value of y to make the summation equals to 4?
3.
3, right? So this is one case.
Yes,
Or
ma'am.
the second case can be x is equals to 2 and y should be equals to
2.
2, right? Next can be that x is equals to 3 and y should be equals to
1.
1, right? So these are the possible cases when the summation will be equals to 4.
Yes.
Any
Yes,
other
ma'am.
possibility?
No, ma'am.
No, right? So now we have written all the cases. We have to find these probabilities. So you can see this is what. Can you please mute your mic? So this is the probability of that x is taking value 1 and y is taking value 3. So we have to use this joint PMF. Okay. So this is nothing but the joint probability of x and y. Okay. So this is x plus y divided by 36. So x is 1, y is 3 divided by 36. Okay, similarly we can find for other cases x is 2 plus y is also 2 divided by 36. Okay, then x is 3 plus y is 1 divided by 36. Is this clear to everyone?
Yes.
Okay, so when you solve, it will be 1 by 3.
Ma'am, in this case, where we're finding the probability of where x plus y is equal to 4, what we will call this, means whether it will, what it will be called, this probability.
Okay, so you are trying to call it as a marginal or conditional something.
Yes, yes, like that. What it will be called.
So it is not a marginal or conditional, it is just a probability. Like what is the probability that the summation of x plus y will be equal to 4? This is simply
Okay,
this
it's
only.
just like a separate case only.
Yes, yes.
Okay, okay, okay.
Is this clear to everyone?
Yes.
Okay, then the similar question. I'll try to solve this one. So here the answer is 1 by 3. So option number B is correct. Now try to solve this one.
So, ma'am, 2 by 9.
2 by 9. Okay. So we have to find probability that x minus y is equals to 1. So what can be the possibilities?
T2,
3, 2,
X3, Y2, and X2 and Y1.
1. Yes.
So we cannot start with 1 x equals to 1, right?
No.
Sure.
Yes.
Okay, so x will be starting from 2 only.
2, 2,
Okay, so x, when x is 2, then y should be definitely is equal to 1.
1.
Next can be then x is equals to 3, then y should be equals to 2.
2.
Yes.
Any other possibility?
No.
No, ma'am.
No, right? Is this statement clear to everyone?
Yes.
Okay.
Yes, ma'am.
Now we just have to simply
Yes, ma'am.
write the joint PMF.
Yes, ma'am.
So it will be 2 plus 1 divided by 36. Then 3 plus 2 divided by 36. So it is 3 plus 5 divided by 36. So 8 divided by 36, which is 2 by 9. Okay, so 2 by 9 is the correct answer. Is it clear?
Ma'am,
Hmm.
one basic note out here. Why are we adding it here?
See, these are like the possibilities. So whenever you have a or condition, we add, right? If you have studied it in the statistics 1 course in probability.
Yes, yes,
Okay,
clear,
and
ma'am.
whenever there is an and condition, then we multiply, right? So you can see that one possibility, like these are the different possibilities. So only one can occur at one time, right? So we are adding all these different possibilities. Okay.
Okay, ma'am. Yeah, clear. But in the stats and all this, the question was framed in an English sentence. Now everything is converted into the mathematical way.
Ah, yeah,
Is
it
it
is
so?
then.
More or less. Okay. Yes, ma'am.
Now the next question is this table one. So we are given the joint PMF of two random variable in this form. So in the previous question, it was in the functional form of x and y. Now it is given in the form of a table. Okay, and you have to find the again you have to find the marginal of x and y. So how can we find the marginal here?
By adding up all
By
the
adding the
row
rows
and
and
column
columns.
Or
values.
yes.
Yes, so we just have to add the rows and column values. Okay. So if I add these values, what marginal I will get? X or y?
Y. Y.
Y, right? Because why? Because these are the values of y. So these, if we
Yes.
sum, if we take sum, so this will be 0.2, right? This will be
Yes,
0.3,
yes. Mm,
this will be 0.35,
35, 0.1.
1.5, right? So for the value, when y is taking value 0, okay, the marginal will be 0.2. When
Yes.
y is equals to 1, then the marginal will be 0.3. Okay, it is like this. Okay, similarly, we can find the marginal of
X.
x as well. So this is for y. Okay, here we can find it for x. So just add all these values.
0.20.
0.2, 0.5, 0.25.
0.5.
25.
0.25.
Right? So now I can write it in the separate table as well, that when x is taking values, x is taking values 0, 1 and 2. Okay? 0, 1 and 2. And the probabilities or the corresponding marginal, it is 0.25, then 0.5, and then 0.25. Okay, this is the marginal PMF of x. Now I can write it for y as well. So y is taking values 0, 1, 2 and 3. 0, 1, 2 and 3, and then marginal for y. So it is 0.23, 35 and 15. Okay, so this is the marginal for y. So now if you want to check the conditions for a valid PMF, you can see all the probabilities are greater than or equal to 0, right? Okay, and the summation of all the probabilities should be equal to 1. So So if you take the summation over these values, it should be equal to 1, right? And when you
Yes,
take the
ma'am.
summation of these values, these probabilities, this should also be 1. You can check it.
Ma'am, y has also 1, 0, 1, 2, 3. Can you solve the of the table, please? This is the marginal probability for y, right?
Yeah, these values are for y and these are for x.
These are the marginal ones.
Yeah, marginal probability. Okay. And
Ma'am,
also,
a quick question. So the marginal probability of a variable reaching a specific value can be zero, but as long as the sum of all the marginal probability is one, it is perfectly fine, correct?
yes. So one instance for one particular value, it can be 0. Okay, but the summation over all the values should be 1.
Ma'am, the same is actually also true for joint probabilities.
Yes, for joint probability, it is also true.
Okay.
Because the joint distribution is also a valid point probability mass function. So it should
So
also follow
basically,
all the
so
properties.
basically, it's true for all kind of probability distributions.
Yes. Okay, so you can see that in this table, this is what the joint PMF of x and y. Okay, so any of the value will be either 0 or greater than 0. And if you take summation over all these values, okay, these are the values taken by joint PMF. If you take the summation, that will be equal to 1. Okay, you can verify this thing. Is it clear?
So far, ma'am.
Anyone else who has any doubt? Okay, so we have seen the marginal PMF. Now one type of question could be there where one of the value will be missing. If you have seen the activity questions, it will be something like the value is not given and it is written like A. Okay, and suppose this value is also given to you. So basically in this table, some of the values will be given to you and some of the values will be missing. It will be like A, B or C something. So you can use this property of PMF and you can find those values. So you know that the summation of all these values should be equal to 1.
1, yes.
Okay, so you can use that property, or suppose in this table how you can find it will be 0.2 minus 0.10 plus 0.05, right?
Yes.
Okay, so you can use these properties and find out the values which are missing in the table. This kind of question could also be there. Okay, should I move on to
Yes.
the next question?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So now here is the
This is
conditional
practice
probability
assignment or
question.
accurate assignment.
Sorry, what?
This is practice assignment or activity questions.
These are not practice or activity. These are like questions which are based on the topic of week 1. It is not the exactly same questions, but similar to that.
Okay, ma'am.
Okay, now you have to find this. You just write this probability and then I will show you the table.
Ma'am, can you please explain how to interpret this? It means that given random variable y has value more than 1, we have to find that probability of x in nay, value of x in between 0 and 2.
Yeah, see. So
Given y,
this, okay. So you are given this probability. Okay, this is the conditional distribution, right? Conditional
yes,
probability. So
yes, yes.
simply you first you can write. You just write the like joint, okay, or the intersection part. Okay, you have studied these things in your statistics 1 course.
Yes.
So this is what like x should be between 0 to 2 and y should be greater than 1, and in the denominator it will be probability of y is greater than 1. Okay, this is
Okay.
something you have to find. Now you will use the table. So you can see that what all values are taken by x and y. So x is taking values 0, 1 and 2. Okay, so this is the range of x. So you have to check what values x can take in that condition. And y is taking values 0, 1, 2 and 3. Okay, so we know that these are the values for x and y. Now you try to find out this part. So x is between 0 to 2. Okay,
1.
and the range of x is 0, 1 and 2 only. So it is obvious that x should be equal to 1,
1.
right? Now y is greater than 1 and the values taken by y is 0, 1, 2 and 3. Okay, so what values can y take?
2 or 3.
2 and 3.
2 and 3, right? Then in the denominator also y will be 2, 3. Okay, so now you have to take the intersection part, which means that x is equals to 1 and y will be equal to 2. This is one possibility, or x is equals to 1 and y is equals to 3. Right?
Yes, ma'am.
Is it clear? And in denominator, it is what? That probability y is equals to 2, or it can be y is equals to 3. So we have to basically add.
So, ma'am, in the denominator, it is the marginal probability of y when it is equal to 2 or it is equal to 3.
Yes.
Can you please explain why we are adding both the probabilities in the numerator?
See, this what is this probability? This is probability y is greater than 1, right? So basically, you have to add all the values which are greater than 1. Suppose y is 1. This is
No,
1,
that I
this
am
is 2.
understanding. I am not getting that why we are adding this, because
No,
above
but
we
in
are
See,
saying
cross
y can
calculation
either be
problem.
1, sorry, y can either be 2 or 3, right? It cannot be
yes.
both at the same time.
Okay, got it.
Okay, so it's like or
It
condition,
it will
so
be
we
it will
have
it will be like either this or this.
yes, yes.
Okay.
Okay, so is it clear up to this part?
But
Yes,
if
ma'am.
we do it separately,
Yes,
like
ma'am.
without adding the denominator,
Sorry?
if we add them separately, like p of 1 and 2 divided by p of y is equal to 2, and then add separately p of 1 and 3 upon p of y is equals to 3.
That will be mathematically wrong.
Okay, thank you.
So is it clear up to this part? Any confusion? Okay, I
No.
hope it's clear to everyone. Now we
Yes.
have to use the table. Okay, so you can see this is what? Probability x is equals to 1, y is equals to 2. Okay, so this is the joint probability of x and y for these values. And this is also the joint distribution of x and y when x is 1 and y is 3. And this is the marginal of y at point 2. This is marginal of y at point 3. So we just use all these values. We are given all these values in the table, right? So x is 1, y is 2. Now you just look at the table.
Is it 0.5?
X is 1, this one, and y is 2. Okay, so x is 1, y is 2, which means this value, right? Is it clear?
Yes.
How to see the values in the table? It should be clear to you.
Yes, ma'am.
Okay, so just go in this way. So x is 1 and y is 2. So this is the intersection part. Okay, so this value is 0.20. Next we have that x is 1 and y is 3. This is 0.20 plus x is 1, y is 3. Okay, now see the table. X is 1, y is 3, which means this value 0.05. Clear?
Yes.
Okay, so this is 0.05. Now in the denominator we have marginals of y at point 2 and 3 that we have also calculated already, right? So you can see y at point 2 and 3, okay, 0.35 and 0.15. And in the table also you can see this is 0.35 and this is 0.15. Is it clear?
Yes, ma'am.
Okay, so you just have to put the values. So 0.35 plus 0.15. Now you just have to solve it.
Ma'am, both values you are taking, right? Marginal probability of y is equal to 2 and y is equal to 3.
Yeah, yeah. So we have to
On the,
add these two.
on the upper table, you have identified two areas, like for x also you identified, or only the two
Uh,
values?
See, in the numerator we have joint probabilities.
Yes.
Okay, and in
Ma'am,
the
can you please go to the table?
yes. Okay, so whatever values are given here, these are the joint probabilities, and the values we have calculated these two.
These are the marginal ones, and
Yeah,
that
these are the marginals. Okay, that we
okay.
have got by adding these.
Okay. Okay.
Okay.
So, ma'am, from this question, can I summarize that conditional probability in general conditional probability is a joint probability upon marginal, but according to conditions, it can also be the summation of other
Yes.
joint probabilities upon other marginal probabilities.
Yes.
Because
Yes.
yeah, right.
Yes. So whatever is conditioned, that will come in the denominator part.
Okay.
Okay, and the joint part will come in the numerator.
Okay. And one more thing, as these joint part and marginal parts will be always in a condition like either and not, so there will be a plus operator in between them.
Yes, so that actually depends on the condition given in the question. But
Can you give
like if you are given like this that y is greater than 2, so y will be taking values 2 and 3, then always you have to add these two probabilities.
Can you give an example where there is a application of a multiplication?
Multiplication, not in this case because okay, you will have to see the questions.
Okay.
Multiplication is where is in that condition when you have to take the two condition at the same time.
Both are happening.
Yeah, both are happening together. Okay, then there will be a and condition. Then in that case we take the multiplication of the events.
That I know. I'm asking that can there be a situation in any question like that where we have to multiply these probabilities?
In the upcoming weeks you will see.
Okay.
In week 2 you will see the independence part.
Okay.
Okay, there you will find that whenever we are taking the joint, we are it is equal to the product of their marginal.
Okay.
Ma'am, can I ask a question? Ma'am, in the last question, right, I didn't get why you divided by y equal to 3 and probability of y equal to 2 and plus y equal to 3. That you elaborate that, the denominator part. Why you divided here by 0.335 plus 0.15, this part, ma'am, like
Yeah, this
division.
part.
Reason why you divided it by 0.35 plus 0.15? I'm just asking.
I have just put the values of these. Probability
Ma'am,
of
like,
y is equals to 2 is 0.35 and probability of y is equal to 3 is 0.15.
like I'm not getting why did you divide it by the probability of y equal to 2?
See, this is the formula for conditional.
Acha.
Okay.
Why? Acha.
See, we have discussed these things earlier as well.
Mm-hmm. Okay.
Let me show you once again. So these are the conditional, right? So this is how we have to find the conditional. That's why we are dividing the marginal or whatever is condition.
Okay.
Okay, now this is your next question. Just write it down, then I will show you the table. Okay, first of all, tell me what will come in numerator.
Uh, x can be
P
1, 2,
x
and
equal to
3.
0,
Sorry, 0, 1, 2.
x equal to 0, conditional, y equal to 3.
Okay, so first of all, we have to take the joint of these two, and then in the numerator, the condition part. Okay, now you can see that x is less than or equal to 0, which means x is 0 and 1. Okay, either 0 or it will be 1. And y is equals to 3, divided by probability y is equals to 3. Okay, so two conditions can be there when x is 0 and
Ma'am, what
y
was the
is 3.
range of 2? It was from 0 to 2, right?
Yeah, the range of x
Okay,
was
okay,
0, 1 and 2, and
okay,
for
okay.
y it is 0, 1, 2 and
1,
3.
okay.
Okay, so when x is less than or equal to 1, which means it will be 0 or
0,
1.
1.
Okay, so when x is equal to 0 and y is equals to 3, this is one condition. Okay, then another could be x is equals to 1 and y is equals to 3.
Yeah, yes.
Right? Now we have to see the values in the table. Okay, x0, y3, x1 and y3. So when x is 0, okay, and y is 3, this is the value. Okay, and when x is 1 and y is 3, this is the value. Is this clear?
Yes, ma'am.
Okay, x is 0, y is 3. When x is 1 and y is 3. Okay, are you able to look the values? Like how we find the values? Anyone has any confusion in this part?
No, ma'am.
Okay, so both the values are 0.05. Okay, next we have to find the probability of y is equals to 3. Okay, so y is equals to 3. The marginal is this one, 0.15. Right? Now we can put the values. Okay, so these both are 0.05.
0.05 plus 0.05
Yeah, and divided by
upon
0.15.
0.15. 2 by 3.
Okay, is it clear to everyone? Any confusion, any doubt?
No.
Um,
Okay. Now try to find this one. So can you tell me what it is written? This fx given y is equals to 1 and this 2. What it is actually?
What it is actually?
Ma'am, probability of x is equal to 2 given y is equal to 1. Condition of y is equal to 1.
Yes. Okay, so it
Divided
is.
by y is equal probability of y is equal.
So it is nothing but the conditional probability. Okay, so x is equals to 2 given that y is equals to 1. Okay, both are the same thing. It can be written in the probability form or it can be written in this form. Okay, distribution form. But these two are same. You should be able to identify. Now it is conditional probability. So again, this will be x is equals to 2, comma y is equals to 1, and in the denominator it will be y is equals to 1. Right? Is it clear?
Yes, ma'am.
Again, we have to see the values in the table. So x is equals to 2 and y is equals to 1, and the marginal of y at 1. So x is equals to 2 and y is equals to 1. So this is the value. Okay, and y is equals to, it was 1, right?
Yes,
So
ma'am.
for y is equals to 1, the marginal is 0.3, this one. Okay, is it clear?
Yes, ma'am.
Okay, so 0.05 divided by 0.3. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, then this is your next question. So this question is based on that topic that we were discussing, that n, capital N is following Poisson distribution and capital X is following binomial. So tell me. So here the question is A and B are playing a game. And one more thing, that in that question, in that statement, when X was following Poisson distribution, it is true for uniform distribution as well. So watch the lectures, you will see it there. So A and B are playing a game. Okay, A rolls a fair six-sided die and B flips a fair coin as many times as the number shown on the die. Okay, so this is our experiment. Now we have defined these two random variables. So X is representing the number shown on the die. The number shown on the die can be 1, 2, 3, 4, 5 or 6, right? Because we have a fair die. Then Y is representing the number of heads obtained by B. Are you able to understand the question?
Yes, ma'am.
Okay, so what we are doing, we are playing a game. So A is throwing a die, and then B is flipping the coin as many times the number shown on the die. So suppose A throw a die and a number 3 comes on the die. Then B will flip the coin 3 times. Okay, it is like this. Now X is representing the number shown on the die. So X, suppose it is 3, then X will be 3. And then Y will be representing the number of head obtained by B. So okay, so B will be flipping the coin 3 times. So out of those 3 times, how many times we are getting the head? Okay, so that is represented by Y.
Ma'am,
Yes.
I could not understand what you were trying to say when you talked about a uniform distribution a while back.
See. So I was saying that in that statement I told you earlier, it was capital N following Poisson distribution, right?
Yes.
So here you can see this question is for, you can see A is
Binomial. X is binomial. Y is binomial.
Y will be binomial, but X can be uniform. You can see that X will be taking values 1, 2, 3, 4, 5 and 6, right?
Yes.
And the values, the probabilities will be 1 by 6 for all.
Yes.
Okay, since we have a fair die. Okay, so you can see that here our X, or you can say capital N, is following uniform distribution.
Yes.
Okay, and our Y, that will be following binomial distribution.
So what were you trying to indicate when you talked about uniform distribution?
Yeah, so here you can see that this X is following uniform.
That I understand. Is there a specific point you are pointing at when you said that?
No, I was just saying that earlier I told you for Poisson distribution, and in this experiment it is following uniform. So
Okay.
that statement is true when X is following uniform also.
Okay, so you were saying that the distribution can also be uniform distribution.
Yes.
Okay.
Ma'am, but this, I can understand X is a uniform distribution, but we can also say that it's binomial because if one of the value occurs, say for example 3 has occurred, remaining 1, 2, 4, 5, 6 will not occur, right? So it can also be seen as a binomial distribution.
For X?
Yeah, X for X.
But in this case, we have to see every other value, na? We have to see all the values of X, then it cannot be binomial in this case.
Yes, in this particular question, it cannot be binomial.
Because if one value occurs, none of the other values can occur. So it's 1 by 6 is 1 by 6 is for one value. The remaining 5 by 6 will be the probability of the binomial. Can we take that in that way? Because the rest of the
Yes,
numbers
that
will
is
not
right.
occur.
That
No, hold on, Rohit, please hold on. I am asking question to ma'am. Let her answer the question.
See, that is a different thing you are asking, that if 3 occurs, then other outcomes will not appear.
Yeah.
But you can see we have a fair six-sided die. So we have the possible outcomes 1, 2, 3, 4, 5, and 6. And all the outcomes have the same probabilities, which is 1 by 6.
That part I understand. I'm not questioning if it is a uniform probability. I know it is a uniform probability, but can we also treat that as a binomial? Is what I'm asking. That's my question.
So I don't understand how
Because
you are
it's
taking it binomial. This X.
because any one value can occur out of the 6 possibilities. So 1 by 6 will be the probability of occurrence, and 5 by 6 is the probability of non-occurrence. So that's the binomial distribution.
Hi, I'd like to say that since this is a single repetition thing, that's why it's not binomial. In binomial, there are a certain number of trials. Here, the number of trials is 1. Hence, it's not binomial, it's uniform.
Okay, so if you need to have more than one to
Yes.
make it.
Since in binomial distribution, you have fixed number of trials. And here we are not talking about the trials and all.
Okay, it's only one. Okay, fine. Thanks, I understood. Thank you.
Okay. For Y, we are saying that we will flip the coin as many times the number is shown on the die. So for Y, we have fixed number of trials. Okay. So suppose if 3 appears on the die, we will be flipping the coins three times. Okay. So in that case, we have fixed number of tries. And we are flipping a fair coin. So the probability of success will be 1 by 2. Right?
Okay, ma'am. Thank you. Understood.
So now can you tell me what will be the possible correct answer?
A and D.
A and D. Why not B and C?
Ma'am, because 0 could never come, so range of I could never be
B and D,
B. And C is because in binomial notation we take the one probability of success, which is not 1 by 4.
Yeah, so
Ma'am, B and D.
options. Yeah, okay. So correct option will be B and D. So
B and D.
yes, let me see. So C and D you will be clear with, because it is written that X is 5. Okay, so N will be 5 only, because we are flipping the coins 5 number of times, so N will be 5. And we have a fair coin, so the probability of success will be 1 by 2. So that is, I think, no one will have any doubt in this part. And in A and B, you can see Y is representing the number of heads. So here you can see that if we are flipping a coin 5 number of times, maybe we are getting tail all the 5 times. Then Y will be equal to 0. No head. Y is representing the number of heads.
Okay, ma'am. Okay, got it.
Okay.
Yes, ma'am.
It can be minimum 0, no head. or maximum it can be 5 because we are flipping a coin 5 number of times. So maximum it can be 5. Okay, so 0, 1, 2, 3, 4, and 5. Now is it clear?
Yes, ma'am.
Ma'am, can you explain option D? That I did not understand, that expression.
See, we have a fair coin, right? And for a fair coin, the probability for head and tail is same. It is 1 by 2.
Yeah, right.
Okay, so the probability of success P will be 1 by 2. This thing is clear?
Right. Yeah, that is clear.
Okay, and here x is equals to 5. X is equals to 5, which means 5 number appears on the die. Okay, so B will flip the coin 5 times.
Okay,
So which means for this random variable y, we have 5 trials.
Okay, got it.
Okay, so that's why the number of trials will be 5.
Okay. Ma'am,
In the question, x is equal to 4 is given. Is it a typo error or did I interpret anything wrong?
Where x is equals to 4? Sorry.
In first
The
part.
question.
Yeah, ma'am. That's the question.
Okay.
If x is equal to 4,
yeah. This is a typo.
None of the
Yeah, this
answers
is a. It will be 5.
Okay, yeah. Now the answers are right. Yes.
Yeah. Okay, now is it clear?
Yes, ma'am.
Yes, ma'am.
Okay, then try to solve the second part. So we have to find the probability y is equals to 2 given that x is equals to 5. Okay, already we know this distribution y is equals y given x. Okay, so for this particular question, we directly know this distribution. Okay, that y given x is following binomial distribution, so we can directly use the PMF of binomial. Okay, so if suppose it is following binomial distribution, okay, then it is what NCY. Do you all remember the binomial PMF?
NCY p to the power y on 1 minus p to the power n minus y.
Okay, so we have to use this PMF. So you can see that n
Ma'am,
is
n minus
fixed.
y.
Yeah, sorry, n minus y. Okay, let me write it clearly. It will be NCY p to the power y and 1 minus p to the power n minus y. Okay, so here you can see what will be the value of x in this case. See, this is different. Do not get confused. This is just I have written the PMF of binomial. You can take any other variable as well. Now, how can you put the values?
Will we take bias 2
5C2
and NS5?
So I'm writing it as Z so that no one get confused. Okay, so now here x is equals to 5 means it will be following binomial distribution with 5, right? And we have fair coin, so p will be 1 by 2, right? So 5c. Now what will be the value here?
2,
right? Okay, because y is equals to 2, which means it is saying that out of the 5 trials we are getting 2 number of x. Okay, so out of 5 trials we are getting 2 number of x, so 5c2. Then p is 1 by 2, so 1 by 2 to the power 2, 1 minus 1 by 2 to the power 5 minus 2. So value of 5c2 and this will be 1 by 2 to the power 2, 1 by 2 to the power 3. So it will be 10 into 1 by 2 to the power 5. 5 by 16. Right? Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Should I
Ma'am,
move on
could
to the
we
next?
actually solve it using the conditional formula? Like expanding like using the conditional formula?
See, we do not know the distribution of y explicitly. We know the distribution of y given x. Okay. So for this type of question, where y is dependent on some other variable, so in that case we will be using this formula. If you know the joint PMF of x and y, then we will be using
Oh,
the previous method. Okay, here we do not know the joint and all, but we directly know the formula, like the distribution of y given x. Okay.
okay.
Ma'am, like you wrote P is probability of y is equal to 2 given x is equal to 5. But here the formula, like how can we understand, okay, if z is equal to y and this formula what you applied, no? How we understand, okay, this will be applicable in here?
See, do you understand how it is binomial?
Yes, yes, ma'am, that I understood. Even the formula also I can understand, like the probability of
Yeah.
z is
So
equal to
you can see that in this formula, what is the value of n? Okay, whenever y given x is following binomial distribution, the value of n will be decided by the value of x.
no, ma'am. The formula which you wrote, no, on the in the bracket, in the
Okay.
rectangular bracket. So that formula says probability of z is equal to y, right?
Yeah, z is equal to z, small z.
Small z. Okay. So probability of z capital Z is equal to small z. So that formula is okay. NCY and probability of y into 1 minus
Yes.
y, 1 minus y. But here it is there. Probability of y is equal to 2 given x is equal to 5. So how this
Yeah.
condition matches
So
this?
you can just take that this is, you can suppose this is a variable z.
Okay.
Okay, you can take that this is some random variable. You can write it like that, that y given x is some z.
Okay. In
So
that case,
this particular random variable, this whole, not separately x or y, this whole variable is following the binomial distribution. Now you
okay.
just forget about y and x. You see the formula, the parameters. So it is following binomial distribution, and what are the parameters? So your n will be equal to 5 because the value of x is 5. Okay,
Okay.
and the probability of success depends on your experiment. So here we have a fair coin, so that's why it is 1 by 2. It will not be 1 by 2 always. It depends on the experiment you are taking. Okay, so here we have
Okay.
fair coin, that's why the probability of success is 1 by 2.
Okay.
Okay, now you just simply apply the PMF.
Okay, ma'am.
Okay, so
So
this
you are telling that
basically,
y given x that we I can consider is equal to z.
yes, you
That
can
kind
take
of
that this is some, you can understand in
that.
this way that this is some variable which is following binomial distribution.
Okay, 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 ma'am.
Okay,
Yeah.
now is it clear?
Yes, ma'am.
Anything else? So the next question is based on the multiple random variable. Okay, so this is how we can define, someone was asking this question, how we can make the table. So this is how we can write a joint PMF table for more than two random variables.
Ma'am,
First of all,
here the fifth column, what it's stating?
so it is the joint probability. So when random variable x1 is taking value 0, x2 is taking value 0, x3 is taking value 0, and x4 is taking value 1. So what is the joint probability of this event? This is 1 by 6.
Okay.
Okay. So earlier it was like x and y. So x was 0 and y was 1. So when x is 0 and y is 1, then it was some value like this. Okay. So now it is like x1 is 0, x2 is 0, x3 is 0, and x4 is 1. Then if they occur at the same time, then their joint probability is this.
Okay. So basically, the format of table has been changed.
Yes. Okay, now try to solve the first part. So I have explained the formula earlier, right? So this is what fx1 given x2 is equals to 1, comma x4 is equals to 2, 0. What will come in numerator part?
And what is the 0 denoting, madam?
So 0 is basically representing the value of x1. Okay, so x1 is taking value 0, and this x2 is 1, x4 is 2.
Ma'am, probability of x1 is equal to 0 given that x2 is equal to 1 plus probability of x is equal to 0 given that x is equal to 4 is equal to 2.
Yeah, so in numerator we will take the joint of all the three, and in the numerator whatever is condition that will come. So probability that x2 is equals to 1
and
and x4 is equals to 2. Now we have to see how we can find these probabilities. So in the first part we are given x1, x2 and x4 only, and x3 is not here. So whenever we have to find the joint like this, so yeah, this part. So when we were discussing multiple, we have seen this type of the joint of x1, x2, the joint of x1, x3, when we are given more three variables. So what we were doing when we have to find the joint of x1 and x2, we were taking the summation of joint over the other variable, which is x3, right? So in the same way we have to find in this question as well. So what we have to do, we have to take the summation of the joint, okay, over the range of other variable, which means x3, keeping these values fixed. Okay, up now don't get confused. Simply what you have to do, x1 is 0, x2 is 1, x4 is 2. So just look at the table first. x1 is 0 is in these three conditions. Now x2 should be 1. x2 is 1 here and here also, not in this. So we will remove this part. Then x4 is 2. So x4 is 2 here only. So we have to take the summation of this probability. So which is a single case here, so it will be 1 by 6 only. Do you understand this part?
Yes, ma'am.
Okay, suppose we have few more questions based on this. But okay, let me explain.
Ma'am, is
So
that
we
the
have
answer? Like 1 by 6 is what you're saying is the answer? Or
no
you just solve
1
the
by
numerator
6 is numerator part only.
Okay, okay.
Okay, so x1 is first of all you have to see the cases. So x1 0 is here, then x2 is 1 here, and x4 is 2. So this is the only case when all the three values are satisfied. So you can
Right.
see x, this is like x1 is 0, x2 is 1, but x2, x4 is not 2 here,
Yeah,
right?
yeah.
So this will not come.
Yeah, yeah.
So this is the only case. So we have to take the corresponding probability, which is 1 by 6.
If there was another row, if there was another
Yeah.
row with the
Yeah,
same
then we'll
set
take,
of x1, x2,
yeah.
x4, but a different value of x3, then we would have added those two
Yeah.
probabilities
So
because
suppose, just suppose for an instance, this is 0, 1 and 2. Then what we will do, we will add these two.
okay,
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 so
and
basically
that's
what
also
we,
the numerator part, correct? Ma'am?
yes.
Numerator, okay.
Yes.
Yes.
Ma'am,
Uh,
what if is x3
uh,
x3 would be 1 or 2 rather than 0?
So no matter what is the value of x3, we have to take like
You have to
summation.
take like summation.
Okay.
Value of x3 could be anything. You have to take those cases where x1 is 0, x2 is 1, and x4 is 2.
X3 is not in the question. That's the
Yeah,
reason.
x3 is
Doesn't
not
matter.
here. So basically what we are doing, we are taking the summation of joint over the range of x3. So x3 could be anything. It can be 1 or 2 or 0 or anything.
So, so finally, how do I solve it?
So you have to find those cases where x1 is 0, x2 is 1, and x4 is 2. Simply look at those cases. So here in this particular, we have only one case.
So numerator will become 1 by 6, right?
So we will take this probability, which is 1 by 6. Okay, now.
Ma'am, ma'am, in the previous formula while you are explaining, no, you are telling we will take x3 also on the summation part, right? So
Yes.
how are you considering that here?
So that you can see that we are taking the values of x3. But here we have one value only. See, we have fixed the value of x1, x2, and x4.
Yes, correct.
So we are getting only one case. If we are getting the values like this, this is 0.
We are putting the value of x3 as 1. Is it that? So we are getting the 1 by 6 divided 1, so that it becomes only 1 by 6.
We don't have to worry about the value of x3 here. Suppose this is also one case, okay? Just consider this is 2. Then 0, 1 and 2. This is also our case.
Yes. Yes.
So we will add these two. This one and this one. So here you can see the value of x3 is 0 and here is 1. So basically we are taking the summation of the joint when we are varying the range of x3.
Okay. Okay.
Keeping these values fixed, x1, x2, and x4.
Okay, so that x3 will be applied when we have multiple entries for that. Like for example, 0, 1, 2, 0, 1, 2, like that. If we have multiple
Yeah.
options available, then we will consider
Okay,
that
see,
x3.
we have other questions as well. Okay, you will see the similar kind of thing. Then you will be able to understand, I guess. Now, next
Ma'am,
we
I have
have
one question.
to find, yes.
Ma'am, like in a previous question, we were doing when doing conditional, we were when there was an and in between, we multiplied, for example, x1 into x2 plus x1 into x1. Like there was a multiplication in between, right?
Multiplication
Uh,
plus summation, I guess.
like in a previous question, when we are dealing with x and y in a conditional, we didn't just like take it in a single bracket. We separated it into
See,
there was an
there the
and.
values were different. That's why we were taking like that. See, in this case, you see, in this case we have x is equals to 2 only and y is equals to 1. We are not adding something, right? Okay.
Like in the previous question before
Yeah,
this,
so
like
that's what I'm saying. So here we don't have anything else. We are not adding, but here you can see that x is 0 and 1. So we have to take both the cases when x is 0 and y is 3, and x is 1, y 3.
so in the case of like different variables, you are doing this, or
I think you are getting confused. See here the values of x is more than 1. So we have to take all the cases. X is 0 and y is 3 fixed. Or it can be x1 and y3. So that's why we were
okay.
taking the both the cases. Okay. Now how you have to solve it here? See, the next we have to find x2 is equals to 1 and x4 is equals to 2. Okay, so we will add all the cases where x2 is 1 and x4 is 2. Simply like that. Don't think about anything else. We have to add all the cases when x2 is 1 and x4 is 2. So x2 1, x2 is 1 here and in these three cases. x4 is equals to 2 when here and here. So this instance will be cancelled, right? And this one also. Are you able to understand?
Yes.
Only these two will be added. Now, are you getting my point? What I'm saying?
Yeah, ma'am, we are getting.
Okay, so we just have to add all the cases where you are getting these values of x1, x2, x3, and x4, whatever is condition, like whatever is there. So here we had only three, x2, x3, and x4. So we were looking for that only. And then denominator we have x2 and x4. So when x2 is 1 and x4 is 2, both the conditions should be satisfied. Okay, so these two cases are there. So we have to add these two, 1 by 6 and 1 by 6. Okay, so this will be 1 by 2. Okay,
Ma'am,
see.
this x21, ma'am, this x21 and x22. So like we have two cases, so we are adding 1 plus 6, 1 plus 6. Okay.
Yes. Okay, so we just have to add these two probabilities, whatever is written there.
Okay, okay, ma'am.
Okay. Now see the next question. I think then it might be more clear. So next we have this probability. Okay. So probability that x3 is equals to 0, x4 is equals to 2, given that x2 is equals to 1. Okay. Again, in the numerator it will be the joint of all variables. So x3 0, x4 2, and x2 is equals to 1. And then whatever condition. So x2 is equals to 1. Okay. Now in the numerator we have to add all those cases where x3 is 0, x4 2, and x2 is 1. Okay. And for the denominator part x2 equals to 1, we will add all the cases where x2 is 1. Simply like that.
Ma'am, like why are we adding cases? Cases they are not multiplying.
Uh, okay, so if you relate it with the previous thing, what we are doing whenever we are finding the marginal, okay, when we are giving the joint, we add all the probabilities, right? Same thing we are doing here also. Okay, but the format of writing is different. So here we are given the joint in the table format. So we are doing the same thing. We are adding the joint only. Okay, we are adding the joint only over the range of other variables. Okay, same thing we are doing. Okay, it is just like different representation. So earlier it was written in the function form in the first question, x plus y divided by 36. And here we are written all the values. Okay, so we are doing the same thing. We are adding the joint probabilities over the range of other variables and keeping these values the fixed, whatever is given. Okay, so now x3 0, x4 2, and x2 1. Now look at these cases. So first of all, x3 0. So x3 is 0 here. Now x4 should be 2. So x4 is 2 here. Then x2 is 1. x2 1. So x2 is 1 in these two cases also, but the other values are not satisfied. So we don't have to take those cases. We have to take only those cases where we are satisfied, like all the values are satisfied. So in these two cases only, we are getting the values of x2 as 1, x3 as 0, and x4 as 2. We don't have to worry about the values of x1 here. Okay? It, it can be anything. So here we have to add these two.
Okay, ma'am.
Is this clear?
Yes, ma'am.
Okay, so in the numerator it will be 1 by 6 plus 1 by 6. Now for numerator we have to add all the values, all the cases for x2 is equals to 1. So x2 is equals to 1. x2 is 1 here and all these. So we'll add these 4 cases. Okay. Now is it clear?
Yes, ma'am.
So we have to add 1 by 6 4 times. 1 by 6 plus 1 by 6 plus. Okay, now is it? Are you able to understand?
Yes, ma'am.
Okay. Now try to find out this value. Fx4 2, which is nothing but the probability that x4 is equals to 2. Okay, x4 is equals to 2. Now tell me what will be the correct cases for it.
1 by 6 plus 1 by 6. Only two cases we have.
Yeah, tell me the row number.
4.
Row number 4 and 6.
Number 4 and 6. So you can see x4 is 2 here and the last one. We have to add these two. Okay, so don't worry about like anything else that we have seen earlier. If you are given the question in this format, you have to see the values in this way. So it will be 1 by 6 and 1 by 6. So basically you have to add 1 by 6 plus 1 by 6. If you have any doubt, you can ask.
Ma'am, where we will get this PDF?
You will get this PDF on the portal itself under supplementary content.
Okay, ma'am.
Okay,
Ma'am,
one last question.
Ma'am, if you can go for a second to the previous question, not the previous one, the earlier one. One question.
I think we have another session starting at 8. So
Yeah, so this is the last question,
yeah,
then we
and
will end
complete
the
this,
question.
and then go back to the previous one. That will be great.
Yeah, okay, so this is the last question, just complete it, and then you can join your next session. Okay, so here we have to find the range of x2 when x4 is equals to 2. So given that x4 is equals to 2, you have to find all the values that x2 is taking. Okay. x4 is equals to 2 is fixed. Again, look at the table. Can you tell me x4 is equals to 2?
No, only one, right?
Yeah. So x4 is 2. In that cases, you have to find the value of x2. So you can say x2 is taking value 1 and 1. Okay, so 1. So x2 given x4 is equals to 2. So this range will be 1 only. Otherwise, x2 is taking value 0 and 1. But based on this condition, it is taking value 1 only.
Why 1, ma'am?
See, you are given this condition that x4 is equals to 2. Okay. So first of all, see the cases, those cases where x4 is equals to 2. x4 is 2 here and this. Okay. Now in these two rows only, you have to see what values x2 is taking. So x2 is taking this value and this one. You can see both are 1.
So the question
If it
is
is
asking
0,
for range.
yeah, it is asking for range.
Range, not the probability value.
Yeah, not the probability, it is a range.
If it's the probability value, then we have to say 1 by 6. Since the question is range, we have to give the value of
Then
1.
it will be different. Then you will take the joint of x2 and x4 and divide it by x2, x4 is equals to 2. Okay.
Okay, ma'am.
So here we have to find the range. Okay, so range of x2 when x4 is 2. So x4 is 2 is fixed. Now see, in this situation, the value is taken by x2. Okay, so it is 1 only. In case if it is 0, if it is written 0 here, then it will be 0 and 1. In that case only. Okay, but here we have 1 only in both the cases. Okay, so it will be 1. I hope it's clear now.
Oh, yes, ma'am.
Okay.
Ma'am, next session when it will be, ma'am?
You can leave your session. Like
No,
leave
ma'am,
this
next
session.
session, when will be the next session, ma'am?
Okay, it will be on Tuesday.
And you will be taking the next session, right?
Yeah, most probably.
Okay.
In the next session, ma'am, what will be covered?
So next will be your doubt session. You can ask your doubts of week 1.
Okay.
Ma'am, even the graded one.
Graded assignment, no. Not graded assignment questions you can discuss after the deadline only.
Ma'am, there is tomorrow. There's one more session of TA.
Yeah, it will be TA session.
Okay, thank you, ma'am.
Thank you very much, ma'am.
So, ma'am,
Thank you very
tomorrow, ma'am,
Thank you, ma'am.
in tomorrow's session, which is a
Session,
TA
ma'am.
session, will that be a revision kind of a session, or that's also a doubt clearing session?
That depends on TA actually.
Okay.
Ma'am, this is the first instructor-led session, right?
Yes. It is the first session.
But going forward, this will continue, I assume. Or, because last week we never had a TA session. The instructor session. Only TA session.
Today is the first session.
Okay, thank you.
Thank you, ma'am.
Yeah, thanks, everyone.
Thank you, ma'am.
Thank you, ma'am.
Yeah, just try to solve the questions of week 1 and then we can discuss it in the Tuesday session.
Okay.
Okay. Bye.